Hey everybody, Mr. Johnston here, and we are going to take a look at a gas collecting technique that involves bubbling the gas through water in order to figure out what the volume of gas that's collected is. We're going to be using water displacement in order to figure out the volume of gas collected. And from there, we can figure out the number of moles of gas collected using a couple of concepts that we've learned: ideal gas law for one and partial pressure of gases for another. And so in this little setup that I have here, we're going to actually be using some Alka-Seltzer to generate carbon dioxide gas. And I'm going to drop the Alka-Seltzer tablet in my flask that's filled with water, and we're actually going to bubble that gas through a tube. And I have a graduated cylinder here that I've filled with water and then inverted. So any gas that's collected is going to be displacing the water out of that graduated cylinder, and then we can measure and figure out the volume of the gas produced. So I need to get my Alka-Seltzer tablet ready, drop it in, and quickly cap it so that the bubbles that are produced inside of this flask move through the tube, and we are collecting that gas in the graduated cylinder. And we can take a closer look at the gas being collected. I'll go ahead and follow the And so it does appear that the reaction is just about finished. So looking at this, I have successfully collected the gas produced from the Alka-Seltzer tablet. The reaction is finished. Now, in order to calculate the number of moles of Alka-Seltzer, or excuse me, the number of moles of carbon dioxide gas produced, we need a few pieces of data. One is we need the temperature of the water so that we can get the partial pressure of the water vapor inside of this graduated cylinder. So we got the temperature of the water is 21 degrees Celsius, which means the vapor pressure of the water is 18.7 mmHg. We also need the atmospheric pressure of the gas in the room, and hence the atmospheric pressure of the gas inside of this graduated cylinder. And so we have an atmospheric pressure of 747 mmHg, that's millimeters of mercury, which is equal to 747 torr. And we also have to keep in mind that this gas that we've collected inside of the graduated cylinder is in fact a mixture of gases. It is carbon dioxide gas and it is water vapor. Since we're collecting the gas through water, water vapor is automatically present in the gas that we've collected. And so the volume of the gas that we've collected looks like, a little tricky to read this because it's upside down. It looks like 75 milliliters of gas. So with that data, we should be able to calculate the number of moles of carbon dioxide gas produced.